What is isothermal process here? So first, the background, again the background. There's a cylinder. We do have a piston. So it contains n moles of gas, pressure, volume. Here P2, V2, temperature T. There's an overall sequence here. No, it's a process in which temperature of gas remains constant. Temperature is constant, so T will be constant. Intensity of gas remains constant. So therefore, U is also constant. So as temperature constant, delta T will be 0. As intensity is constant, so therefore delta U is 0. So from first law of thermodynamics, what we can write here, as we know, dq equal to du plus dw. As du is 0, and moreover this, what we get is like a temperature is constant here. So therefore, PV equal to nRT as temperature constant. So PV is equal to constant. So then P1 V1 equal to P2 V2. So it's a process in which pressure and volume, how they'll be uh, related. So rectangular hyperbola, the curve. So what will happen to temperature of gas? It remains constant throughout the path. Okay, now you have to ask questions like, what makes the volume to increase? I'll supply heat. There's a thing what happened you should catch here. We are supplying heat. What that gas will do, what all you supply heat, it will convert that into work done. What do you mean by work done? It will convert into, say, like the gas will exert force here, P into A. So this pressure force, if a force acts on a body of mass M, there's a piston. The piston will accelerate. Kinetic energy of piston will increase. So what this gas is doing, it is converting heat into work done, or nothing but what is work done by gas. There should be some extrinsic should be available. What is that extrinsic? Here, the kinetic energy of piston. So what this gas does, it will convert the heat into mechanical work. What is W here? Mechanical work. I don't know in chemistry how you study, but here W is what? Mechanical work done by the gas. And there should be some agent. Who is that agent? The piston. So what this in isothermal process, the gas will do, the gas will convert the gas, what it does, it will convert heat into mechanical work. Any amount of heat, yes, any amount of heat you supply, it will convert that heat into mechanical work. Very good thing, no? This is, so in isothermal process, what are the things, no? The gas converts heat. Don't write heat energy, yeah, because heat itself is energy. The gas converts heat into mechanical work or vice versa. It's a very good thing. No, you just put some candle flame or Bunsen burner, you keep it here. So what this piston, conductor and the gas, what they do, the gas will absorb it, and what the gas will do, it will convert that into mechanical. What do mechanical work? The piston starts moving. There's a meaning of this. So there's a meaning of this. Huh? I think the books, they have missed this very badly. since I'm from engineering background, no, so I'm more interested in the applications rather than only mere theoretical idea. Now, what is the isothermal process, temperature constant, delta U zero, dq equal dw? What is there in this? What is there in the book that you are telling? No, what is actually meaning of that? There's a meaning. Huh? What is use of isothermal process? Uh, to keep uh, intrinsic constant, we take isothermal process. I can bring a process where intensity is constant, but it will not be isothermal process. So just mere sentence in the book, what happened? Don't repeat. Don't think that one. What is the use of that is what we are learning here. How to calculate the work done. Work done means something I should calculate this area. Can we calculate area? I think very difficult. No, it's not that easy because it is not some sort of rectangle, square, or trapezium. Sir, I'm seeing trapezium. Is it trapezium? You know enough mathematics? No. You are not in the month of April or May that I don't know anything, sir. Even I don't know addition. Now you know enough of integration, everything. Okay, look at this. Can we calculate area? Not possible, no? So therefore what we do, we will just go for a strip. Elemental strip, let me choose dv. What is the dw is equal to, what shall we write? dw equal to pdv. In any process, nRT by v. So further this temperature constant, so nr volume v1 to v2 or final volume to initial volume, anything symbol. So what is work done? So in terms of pressure, if you want to write the same thing, nRT log of P1 by P2, initial pressure by final pressure, or final volume by initial volume. And this should also be equal to Q, no? I think there's a generalized formula, I'm bringing it. So what is isothermal process? It's a process which will convert heat to mechanical work or mechanical work to heat. What is the molar heat capacity for such a process? Very, 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 very important. For isothermal process, what is dt? 0. So therefore, C isothermal process will be infinity. What do you mean by that? You supply any amount of heat, it will convert into work. Sir, which gas will undergo isothermal process? Anybody? Anybody? Which all gases will undergo isothermal process? Anybody wants to give reason? Which all gases will undergo isothermal process? Vinayaka, Nitesh, lucky you are in online class. Huh? If you're in offline, no. If you're in real physical classes, no, I would have banged your head for your reply. Yes, anybody? Which all gases will undergo isothermal process? Why no answer? Let it be right or wrong. Let it be right or wrong. If it is wrong, teacher will scold. What is there in getting scolding? Nothing wrong, no. Ideal gases, real gases will not undergo isothermal process. Real gases will not undergo isothermal process. Any gas can undergo isothermal product open. Temperature should be constant. So how temperature is constant? We have to maintain. We have to maintain. On its own, not possible. If the piston moves gradually, it is isothermal process. If the piston moves suddenly, then it will not be isothermal process. If piston moves suddenly, means like here, I supply, it means here, action agent, I can also do one thing. Okay, some of you. Again, the basic common sense is missing. Sir, how do I come to know? I never seen cylinder piston. That the rewards requirement of science, no? You want to become good engineer, you must struggle to learn things very clearly. Okay, now this is let me bring a situation for you so that will be easy for you. So there's a piston. An external agent will move this gradually, the piston. External agent, I can apply force. So what happened? The pressure of volume of gas decreased. So shall I say isothermal compression? If I move gradually, the piston, the gas will undergo isothermal process. The temperature of gas will remain. If I move suddenly, though it's a like a ideal gas, and most of you are saying ideal gas. So what all we discuss ideal gas only. Only in chemistry you go for real gases. In physics we must discuss ideal gases only. If I move the piston suddenly, means like this, the gas what happened will not get a time to exchange it. The temperature of gas will change, so cannot be isothermal process. Fine, the gas will not decide what process will undergo. The external agent, I'm an engineer, I'm going to decide what process the gas will undergo. So therefore, which gas will undergo isothermal process? Any gas can undergo isothermal process. Finish over. Any gas can undergo isothermal process. Fine. If I move piston gradually, it's isothermal. If I move piston suddenly or rapidly, like this, then it's a not an isothermal. So if I move like this gradually, then it must be okay. I'm if I move piston gradually like this, then what it is? Isothermal. If I move suddenly, then the gas will not get sufficient time to exchange heat. The temperature of gas will change. So then it cannot be isothermal process. Able to understand? So even how the piston is moved also plays very, very important role. So I'll put it here. If the piston, let me put it in. If the piston is moved gradually towards left, okay, there's a iron conducting cylinder. There's one more condition. So what is this? This is a conducting cylinder. The gas will undergo isothermal process. If the piston is moved rapidly towards left, the gas undergoes, the gas will not undergo isothermal process. Okay, I think so. This is some regarding isothermal process we have. Okay, what about other set of graphs? Pressure, volume, rectangular hyperbola. What about the temperature, volume? What is this process? Isothermal process. You see, temperature constant. Then volume, temperature graph. isothermal process. So all these are the graphs related for isothermal process here. Then pressure, temperature, intensity versus pressure, internal energy versus density graph, or say density versus intensity graph. So I think different types of curves will come across. In temperature versus volume graph, horizontal line, isothermal expansion. Volume versus temperature, somebody please mute it. In volume versus temperature graph, vertical line should be isothermal. Pressure versus temperature, vertical line should be isothermal here. Isothermal compression. Pressure increases, say volume increases, isothermal expansion. Volume decreases, isothermal compression. Pressure increases, isothermal compression. Now, intensity versus pressure graph. So what should be the here? Intensity constant. So therefore isothermal. Density versus intensity. Vertical line should be the isothermal. So density increases means isothermal expansion. So like that, not only don't just believe PV graph. I may bring all these things. The moment you see vertical horizontal lines, so you should be able to identify is it isothermal or any other process here. What about the pressure, volume, density, how they are related? So let's see that one more. PV equal to nRT. Mass of gas by molecular mass. Further, P equal to mv by RT m naught. What do you mean by mass by volume will become density? I need space. I'll shift it to other thing. So I may end up, let me rewrite this equation. So P equal to rho RT by m naught. No. So what is R m naught T? Their constant. So even P by rho will be constant for isothermal process. If I plot pressure versus density graph, tell me how the curve should be. Should be straight line passing through origin. Able to understand now? Getting this one. So all the possible things. Let me shift everything here. All these are isothermal. Only PV graph rectangular hyperbola is not isothermal. So if you check the numericals now, we do have wide varieties of like this. A student must identify what do you mean by isothermal process means all these graphs. That's what I mean to say here. Okay, able to get this one. So P by rho, if you get horizontal line in pressure versus density, will it be isothermal process? Anybody wants to answer? Or it should be straight line passing through origin? Straight line passing through origin only will be isothermal process. If the horizontal line, it cannot be isothermal. Getting the idea? This will be okay. Let's next we'll take the adiabatic process time.